You can identify when a stoichiometry problem involves limiting reactants by the amount of starting information that you are given. If you have a mass or mole amounts, or a way of finding these for more than one reactant, you need to check if one reactant will run out before the other. A traditional metaphor is a recipe for s'mores. In this recipe, you need 2 graham cracker halves, 1 marshmallow, and 3 rectangles of chocolate. But we all know that you can't just buy this recipe in the store. Anyone who has had the pleasure of eating this fun fireside snack knows that you always run out of chocolate first, then graham crackers, then you go home with a bag of unused marshmallows. The methods in limiting reactant problems start with the idea of calculating how many s'mores you can make with a given amount of ingredients. Let's start by thinking about a reaction that produces ammonia, which is vital in our economy. If you start with 0.15 grams of both of our reactants, which again is the key to telling you when you need to do this type of process, when you have more than one piece of starting information, what we're going to do is we're going to convert both of these starting amounts to moles of a product, kind of like if you wanted to figure out how many s'mores you could make total. So since we only have one product in this case, we will choose to convert these to moles of ammonia. I'll start by changing my grams of my starting materials into moles. So for nitrogen, since there are 2 nitrogen atoms, the molar mass is 28.02 grams per mole. And now I will check the mole-to-mole ratio in my balanced chemical equation. I see that there is a 1 in front of nitrogen, so 1 mole of nitrogen to 2 moles of ammonia. And now I'll do the same process for hydrogen. Changing the hydrogen grams into moles, we need the molar mass of hydrogen. And then we'll check the balanced chemical equation for the mole-to-mole ratio. I see that I need 3 moles of hydrogen gas every time I have 2 moles of ammonia produced. Now we'll punch these numbers into our calculator and get 0.012 moles of ammonia, possible if all of the original nitrogen reacts, and 0.0497 moles of ammonia if all of the original hydrogen reacts. Since the nitrogen cannot make as much product in this case, it's like how we can't make more s'mores than you have chocolate. So we say that our limiting reactant is the nitrogen because it can make the least amount of product. It is the limiting feature. If your question asks you to figure out the grams of your leftover product, you should use a rice table, sometimes called an ice table, when you're solving equilibrium problems, to figure out how many moles of leftovers you actually have. Here's what it looks like. You write down the reaction so that you have a reference point for your mole-to-mole ratios. You don't really need to write down the products since we're analyzing the reactants. You need to write down the initial moles. We will figure out the change of moles. And then we'll write down the ending moles. Once we figure out how many moles we have at the end, we can then convert those moles into grams. So that's the main idea for this problem. Okay, so the first step is going to be writing down those initial moles. I didn't calculate moles earlier when I was trying to figure out the limiting reactant, so we're going to have to do that now. I'll take that 0.15 grams of nitrogen and convert it into moles with the molar mass. Shove that in a calculator, and you end up getting 0.00535. I'm including a few extra sig figs for now, and I will round properly at the end. Okay, now it's hydrogen's turn. We will take our original grams of hydrogen and divide by the molar mass. Divide those numbers in a calculator, and we'll end up with this number of moles of hydrogen. Okay, in the previous step, we figured out that nitrogen is our limiting reactant. That means that all of the nitrogen is going to react. So our change of nitrogen is going to be all of it. This means when I subtract my initial moles and the change, I will end up with no moles of nitrogen left over at the end. Next, we need to do a mole-to-mole ratio to figure out from that nitrogen number how much hydrogen was used. So I'll write down 0.00535 moles of nitrogen actually reacting, and use the mole-to-mole ratio 1 to 3. 1 mole nitrogen, 3 moles hydrogen, to figure out hydrogen's value. This step is really crucial in several of our problems that we're going to do throughout the entire course. At this point, we're going to subtract that amount of moles and end up with 0.0584 moles of hydrogen left over. Now this problem becomes simple stoichiometry. I have 0.0584 moles of hydrogen. We can multiply by the molar mass. To end up with our answer, 0.118 grams of hydrogen left over. Now there are about 5 or 6 different ways that you can attack this kind of problem. If this organization doesn't work for you and you find another logical path, go ahead and use it. But make sure that you practice as many of these problems as you need until you master this concept.